Basic electrical engineering. In our previous video lesson, we are learning about the insulating material of solid state, liquid state, insulating materials and gaseous type of insulating material. In this video, we are going to learn the special purpose materials. What is the special purpose materials? For example, what is the material of fused used in this figure as fuse wire? It is an alloy of lead and tin. This is not an insulating or not a semiconductor or not a conducting material. It is a special material. Our electrical engineering is a vast field in which a large number of materials are used for different functions. The materials can be classified as primary materials and secondary materials. The materials which perform primary functions are called primary materials, whereas the material which perform secondary functions are known as secondary materials. What is the difference between these two? Why sometimes it is called primary and some materials are called secondary materials? Primary materials means the material which performs primary functions. The conducting materials, the copper, aluminum used in the material as a conductor, all the things are, it just functions as which perform primary functions, that is called primary material. But the secondary material, it is very special. It is very necessary to use certain materials not directly, but to assist in performing the function effectively and efficiently of the primary. These secondary materials are needed. For example, the structural materials like poles and towers do not perform its function as a conductor for transmission and distribution of power, but support the conductors as a overhead systems like that. Another example we will take. Similarly, the frame of electrical machines and equipments and the armoring in cables. This material do not perform any primary function of the particular equipment, but they perform the secondary function. I mean to say that without the use of secondary material, the primary function would not be effectively and efficiently. It means secondary materials are used for special purpose. So in our electrical engineering, special purpose materials are so many types. Mainly it is categorized as 6 main groups. That is structural materials, protective materials, thermocouple materials, bimetals, soldering materials, fuse materials, like that. What is this protective materials? The materials which are used for protection of various materials and equipments known as protective materials. In electrical engineering, every material and equipment needs protection against atmosphere condition. The most commonly used protective materials are lead, paint and varnishes, steel tapes. Lead is soft, heavy and bluish green metal. It has good malleable and ductile properties. It is high resistant to many chemical actions. It is mechanically weak. It may be used as a pure metal alloyed with other metals or a chemical compound. In electrical engineering, lead is used as plates or grids in storage batteries, as sheeting of high voltage power cables, for making soldering and bearing and anti-friction metals. Lead sheets are used for sound insulation purpose. Mainly lead is used for industrial purpose in many forms. The main functions is soldering of metals and it is used as fusing element also. Chemical form is Pb. It is a very soft material. And it acts as a corrosion resistant material for many chemical actions. It is used as sheathing in cables, battery plates, fuse, link wire, etc. It is malleable and ductile, and its melting point is 327 degrees centigrade and boiling point is 1560 degrees centigrade. Its hardness can be improved by the addition of arsenic and antimony. This arsenic and antimony are used. They are added to the lead to increase its hardness. Thereby it improves its performance. After that, the next category of protective materials are paints and varnishes. We are all know about this paints. Paint, what's its state? Paint is a liquid which after application to an object is converted to a solid film. It is most commonly used to protect color or provide texture to objects. It is used to protect the equipment from corrosion. Varnish. Varnish is a transparent, hard protective finishing used in wood finishing. So these are paints. It gives very good appearance. We are used so many colors of painting to our house also. For our furniture we are used these paints to protect from insects, pesticides. It protects structural materials like steel, wood, poles from corrosion. So different colors of paints are available in markets. For poles also we are applying this type of paints to protect from corrosion. Because of that it is always it is exposed to atmosphere every time, right? So the use of paint increases the life of the structural material. Bitumen is also used as protective coating for material for steel and wood when buried in the ground. It provides protection against atmosphere chemical action of metal and wood structures. Red oxide is used for primer coating for steel poles. Varnish is used as protective coating for wooden poles. Paints used to protect structural materials and equipment from atmosphere condition. Aluminium paint is used for this type of structures. Grey paint for other equipment. Next, varnish. Varnish is very transparent, hard protective finish used in wood finishing and also for other materials. It is also used to prevent corrosion of materials. By applying varnish to our structural equipments, what is the purpose for this? The function of this is to improving insulating properties and to improve mechanical properties. Used for all timber structures to protect from moisture and rain. The next thing is about tapes. Steel tapes are commonly used as protective materials for cables. It is mainly used as protective materials in mining cables, undergrounded cables, for binding of cables, for supporting service cables to avoid sag. See, this is a picture. This is transoceanic submarine cable. It has many stages. Wrapping, steel armoring. Steel armoring is also special material. copper threading, polyethylene insulation, jute covering, oven glass. This is a telephone cable operator. Next is steel tapes. So here we are used this steel tapes and varnish, paints. These are coming under the category of protective material. This is the material which is used to protect the structural materials. First of all, what is a structural material? The material which are used for construction of structures are known as structural materials. See, this is the pole here. The various structures used in electrical engineers are poles, towers, supports for electrical equipments, foundation for rotating machines. The most common used materials for electrical engineering structures are cast iron, steel, wood, cement, brick, reinforcement, concrete. These are used for build-up of the structure. Here, these poles are there, right, in the picture. Cast iron and steel are widely used for the transmission poles and towers frames of electrical machines, tanks for transformers, and a large number of other applications. And wood is a natural material available and is used for poles in distribution of electrical power, like that cement, bricks, some concrete materials are used in foundation of electrical machines. You are, I think, observed, for example, the transformer nearest to your street and nearest to home, all are, they are placed on a well structured material. Some concrete brick construction is there. On the top, this transformer is placed. So this type of supporting factor materials comes under the structural material. So throughout, what is the need for this protective materials? The protective material is needed to support this and to protect this supporting material. An electrical system is an assembly of electrical components, materials, equipments, machines, devices which require electrical energy in order to perform their required functions. These materials and equipments are always exposed to atmosphere conditions. See, just for example, we are taking an example of substation, our overheaded systems. It is always exposed to atmosphere conditions like temperature, moisture, some chemicals during its operation. Due to this atmosphere condition, maybe it damages the equipment and materials and cause reduction of their lifespan. That's why, in order to get effective and efficient operation, the equipment and material need some protection from this various atmosphere condition. So these are the different types of protective materials. Each have their own functions. They are used for decoration. See, paints are used for decoration also, and insulation as well as, or both. The protective materials are protective barrier that shields various parts against harsh environment conditions such as atmosphere, moisture, chemicals, and different weather conditions. So the protective materials are also used to reduce the hazardous, the shock from the human beings, and to reduce the risk to acceptable level. Well, the protective materials are used for providing protection against heat, fire, rain, snow, or from electrical shock, over currents, over voltages, corrosion, environmental hazards, like that. For example, what is the right condition now? We all are awareness about the corona. That's why we wear mask, face shields, gloves, like that. Like that. Here also, the protective shields, protective barriers, or insulation material shall be used to safeguard from electrical shock or dangerous electrical heating or arcing, like that. Here, the materials like PVC, glass, asbestos, rigid laminate, varnishes, resins, papers, Teflon, rubber are very good insulators. Here, insulating material is used as protective coating on electric wiring and cable. So materials like paints, varnishes are used for cooling the material to prevent damages from corrosion. So we have to apply varnish or paints on that as a coating to prevent it from the damages. So these are the protective materials. We already studied about this. That is lead, paint, steel tape, and varnishes. Each and every individual has its own functions. Lead is used mainly for soldering to joints, and also it is used as fusing element also. Like that, paint, it is used from corrosion effect as well as decoration purpose also. So many colors of paints are available. Varnish also we are used. These are the steel plates, steel tapes, which are used in cables around the bedding, armoring. Next is thermocouples. What is this thermocouples? Thermocouples can be used for the measurement of temperature. Depending on the range of temperature to be measured, proper materials are to be selected for a thermocouple. When a couple of different metals or alloys are joined at their ends and the junction ends are maintained at different temperatures, then what happened? An EMF is existed across the junctions. This EMF causes a current to flow from hot junction to cold junction. This EMF depends upon the type of metals or alloys and on the difference of temperature between the junctions. As the EMF and hence currents induced in the couples are due to the difference of temperature between the junctions. Here that's why this combination is known as thermocouple. The EMF is called thermo EMF and the resulting current is known as thermoelectric current. This thermo EMF depends on the type of metals and alloys used. See, these are the thermocouples. Here two junctions, hot junction and cold junction. This green is metal A and pink color is a metal B. Here the EMF produced by a thermocouple is very small and is measured by a sensitive moving coil moving meter. This is a moving meter, blue color. Moving meter. The moving meter can be calibrated in terms of temperature. If the cold junction N is maintained at constant temperature and the temperature of the hot junction is slowly increased, the millivoltmeter indicates definite potential difference for any given temperature of junction M. Here two junctions M and N. The EMF causes a current to flow up to a certain maximum temperature. If the temperature of the hot junction is increased beyond the maximum value, then the current decreases and becomes zero at a particular temperature. The temperature of the junction is still increased, then the current reverses and increases. So what's the principle for this? Overall, the principle of this thermocouple is pyrometer, which is used to determine the temperature of an object's surface. Let's see the properties of this thermocouple. It produces EMF, should not change rapidly with time. High resistance to corrosion. Cost should be minimum. Here see, this is an ammeter. It is used to measure as moving coil. Ammeter is used for the resultant current measuring. Two metals, metal A, metal B is used. Here two junctions AB are formed. These two junctions, the two metals are nickel and it forms nickel chromium and nickel aluminum. Due to these two metals, 12.2 MV EMF is existed. Up to 1100 degrees centigrades it will work. These are the types of thermocouples. Copper constant up to 500 range. Nickel chromium, it is up to 100 degrees centigrade. Iron constant 900 degrees centigrade. The next topic is another special purpose material, that is bimetallic strips. A bimetal or a thermostat is based on the theory that metals expand on heating and contract on cooling. If we give heat to any metal, then it will expand. If it cools, then it will come to contract. It works on the principle of the heating effect of electric current. In previous chapter also, we are used this thermostats in our electrical appliances like electrical iron, kettle, automatic iron box. Like that type of apparatus, we are used this material thermostats. Well, it works on the principle of the heating effect of electric current. What's its function? Its function is a switch on and off the supply automatically at a certain temperature. Here, a bimetal or thermostat consists of two metallic strips of different metals or alloys with different coefficient of thermal expansion. The strips are welded together lengthwise at a certain temperature. The strip will bend and operates a switch or a lever. A bimetal can be heated directly or indirectly. Then when heated, what it happens? It bends in such a way that metal with higher coefficient of expansion is on the outside of the arc formed, and that will with smaller coefficient of expansion is on the inside. Okay, are you followed? I think when this is cooled, then what happens? The element bends in other direction. Here we are used alloys of iron and nickel with low coefficient of thermal expansion and are used as one element of the bimetallic strip. The iron, nickel, constant, brass having high coefficient of thermal expansion is used as other element of bimetallic strip. These bimetallic strips are used in electrical apparatus and devices as relays and regulators. A bimetallic layers are used for overload protection of electrical machines and equipments. In order to maintain constant temperature in electrical heaters, ovens, furnaces, a simple biometric regulator may be used. These are adjustable for a particular current. For example, if the current exceeds certain value, the strip will heated enough to bend and break the circuit. Here this is a diagram. Once the bimetal gets heated, exceeds set limits, it opens a circuit and the apparatus is put off. Two metals will have different coefficient of expansion. The higher coefficient of expansion metal expands more. Overall bending of strip occurs, thus breaking the circuit. Due to this breakage of circuit, no current will flow. After some time, the bimetallic strip is there now, it comes its original position. Then once again it closes the circuit. These are used in electrical appliances as relays and regulators. See, these are the applications of this bimetallic strip in geysers, automatic iron box, thermal relays, regulators. We are used. Geysers, automatic iron box, thermal relays, regulators. Two materials are used, that's why it is called bimetal. Here see, this is a pink and violet colors is there now. This is one material and this is another material. It's combination of two metals. If we are giving heat, then high thermal coefficient will expand. If we cooled, then low thermal coefficient will be contrast. So it changes its shapes. See, this figure is at the time of heating. After cooling, it comes into quite opposite, other direction. So what is a summary for this? In this lesson, in this period, we had studied about what is the meaning of the structural material, what are the primary and secondary materials. Here, primary materials is conductors, secondary materials is structural material. To protect these structural materials, we need the help of these protective materials. Lead, paint, steel tape, varnish, all are coming under the protective materials. These are steel tapes. After that, we are studied about the thermocouple. Two different materials are joined and maintain different temperatures at the ends. Due to that, EMF is induced. This EMF is measured in a moving coil, small millivolts voltmeter. A small EMF is produced. Here two junctions are formed. One is hot junction, another is cold junction. Let's take the example of nickel chromium and nickel aluminum. These are the different types of thermocouples. Copper constant, nickel chromium, and nickel aluminum. Iron and constant. After the next special material is bimetallic strip. Here two metallic strips of AB. Two unlike materials or alloys are used. It have different types of coefficient of thermal expansions. One, it heats, then it opens a circuit. It breaks the circuit due to that in open circuit current was not flow. It presets some current value. If it exceeds the limit, then it breaks the circuit. The continuation of current was not takes place due to opening or breaking the circuit. Then the bulb or the electrical appliance is put off. These are some of the applications used in our bimetallic strip. Geysers, automatic iron boxes, thermal relays, regulators like that. In the next class, we will learn some more special purpose materials like soldering, like that. Okay? Hope you understand this. Thank you for watching this video.